Welcome back, guys. Jason Esteves, part one. We talked about some personal CO2 monitoring, and more in the part two is the cracked heat exchanger and the cracked heat exchanger mode and what to look for when it comes to cracked heat exchangers on your combustion analyzer. What does your O2? What does your CO do? What does your at more of a smaller level? What does your excess air do? Your excessive air? What does it do? So we're going to get into that and cracked heat exchanger mode on the NOVO on this episode. This is the HVAC Know-It-All podcast. I'm your host, Gary McCready. This podcast is sponsored by Cool Air Products, Master, Cintas, and SupplyHouse.com. Go to the show notes and click on the links to check these guys out. So I want to talk about a recent rooftop unit that I worked on. Now, I already knew there was a crack in the heat exchanger. And one of the things I want to tell people about cracks in a heat exchanger, you don't have to take my advice if you don't want, but I've found that this is probably the best route, especially on commercial equipment. Well, I should say in residential too, but it's easy to open up the back of a panel on a rooftop unit and look at the heat exchanger. And a lot of times the heat exchangers, they corrode. And I hate when people say rot because metal doesn't rot, it corrodes, right? Apples rot, bananas rot, metal doesn't rot, it corrodes. It's not an organic substance. So the metal it corrodes where the tubes bend. So the tubes come out of the burner, and that first bend before they go back up on the seam is where a lot of them will start to corrode away. And if I notice that it looks weak in that seam, I'll take a screwdriver and just use minimal force and I'll push it. And if it goes through, you know what? There wasn't a hole there before. Now there is. Yes, I understand that. But that hole is inevitable through the winter in January, February anyway. So you might as well find it in September, October, change it while it's warm, and we're not getting emergency service calls or finding it in the middle of January and shutting someone's heat off. So that is my go-to. If I find it weak, I put it right through. I don't like take a hammer and like try to create a hole. It's
Sure.
just
Sure.
like minimal force. If it goes through minimal force, there's a problem, right? But that same unit, I put the analyzer in. Like rooftops, you don't have like a flue really. You've got like the vent
No.
at so I shoved it in 6 inches, whatever. And the CO was off the charts, right? It was getting 4, 5, 600, but the oxygen didn't really rise all that much. And I was really, really surprised by that when the blower started up. The oxygen was higher than I would say it was like 9.5, something like that. And it was dropping, and then it did come up. I would say it came up maybe a point or two, and then it stabilized there. And coming up a point or two is coming up, but it didn't like have this big jump, but the CO went crazy. So what are your thoughts on that sort of scenario?
You only need 0.5% of oxygen for it to be cracked.
Okay.
So even, believe me, I know. I had the same conversation yesterday because I think it's another one of those industry known things where, well, we were having a conversation yesterday about, well, 2% wasn't that big of a deal. And I go, no, 2% is an enormous deal. So if you understand how this works, a difference of oxygen, all it takes for it to determine if there's an issue is 0.5%. So if you go from 5.5 to 6.1, that's a 0.5% of oxygen. Remember, you and I only play with 20.9% of oxygen. That's all we have in the air we breathe. 0.5% of oxygen is a big difference.
Yeah.
Even in combustion mixture in a good situation, your ranges of oxygen are typically what? 4 to 6%, 7 to 9%. That's a 2% range of good combustion. If I'm off by 0.5% either way, that means my combustion probably isn't that great, and I should get it in the range. But if I'm looking for a cracked heat exchanger, an increase of 0.5% or more, the example I gave before, right? I said it jumped when I was telling you the technician I was with. The CO doubled, went from 29 ppm to 52 ppm. Okay, almost doubled. But it went from 8.9% oxygen to 11.1. Not a big, huge change, but a good amount. If you know combustion, it's a huge change. If you're just looking at numbers, it's not a big one. The problem is that as that gets bigger, your CO starts going from 50 to, okay, a bigger hole, 100, and every different type of system is different, right? So there's no, okay, well, if it goes a 0.5%, you're going to see hundreds of ppm of CO. That's not how that works. Every system is different. But what I'm looking for is, man, all you're looking for is that 0.5% of oxygen change, and I already know that there's an issue. CO is just it's the secondary indicator. Yeah, of course, it's a huge indicator. That's why our heat exchanger test does both, right? It looks at both O2 and CO. But there are situations where I don't want guys to just be trained on looking for one thing or another. I want us looking for what we should be looking for, and it's both. But the real driver is the O2. That's the real driver in the difference, right? But when we do this kind of stuff and when we work with other trainers, we start to realize, oh, wow, I don't think guys know that it only takes a 0.5%, that it starts to change and then it gets worse over time.
That's actually a really good indication, like versus, right? Start, end, it's a 0.5%. So that's pretty substantial. Now, I'm gonna ask you in a minute about the Novo and how to set it up with this mode, because obviously you'd have to perform some sort of update on it. I was at a site a couple weeks ago. I just like talking these stories because they're educational for people, and I want to get your take on it as well. These were two makeup airs, brand new, hadn't been started up, and they sent me there to start them up, and I hate going to startups of equipment. No, honestly, because when I get there, it's like, "Is this done? Is that done? Is this done?" It's like the BAS guy's still working on it. He's not finished. The smoke alarm guys are still working on it. They're not finished. And I'm like, "Why am I even here?" Because these makeup airs, in order to change the supply air temperature to the hallways of this building, we needed a control tied into it, either a remote control that wasn't available or wasn't part of the scope of the work, or the building automation guys had to be finished, had their points tied in, and they got on their laptop and go, okay, we're going to change the supplier from this to that so we can fire up the burner to a greater point. Because I couldn't do that, I had to work with the default setting, which was, sorry, my friends in the US, which was 10 degrees Celsius discharge air. That was the default, and it was 6 degrees Celsius outside. So the range on the control or the burner is 0 to 10. So I check it with my meter, and it's zero 0.6 volts DC is the command. So imagine how much that gas valve is
Okay.
opening. It's opening like a hair. So as I'm taking that combustion analysis on
Sure.
both of the units, not just one, they're both the same. Or yeah, the oxygen O2 is like 18%. It was crazy because there's like very little
Wow.
gas going to that burner. So I just wanted
There's
to
no
throw that out
gas.
there.
Yeah.
There's like no gas at all. It's basically air going through it, right? To maintain that 10
Yeah.
degree.
Sure.
And the access,
Sure.
the excessive air was like 1,000 parts per million because it was mostly air. There's barely any gas. So
Sure.
throw me your thoughts on that when you're working on these modulating systems and you can't drive it up, how you're supposed to figure out like how to get a good draw on your combustion.
I mean, that doing combustion analysis at 18%, there is not much you can do because first of all, it's look there. I mean, there's things you can do, but you're not getting any data for 18% means you probably have zero CO, zero CO2 for the most part because CO2 is calculated from the oxygen and what fuel you select. And combustion's like a seesaw, right? So what happens is when you make adjustments to gas pressure or anything else, when you decrease the carbon and the hydrogen coming in, meaning you're decreasing the gas because you're reducing the carbon and hydrogen, you're not going to create things like CO and CO2. So the more air you have, you kind of run on the air rich side where you almost have zero CO and zero CO2. As you start increasing the gas, that's where you kind of try to land the plane, right? But it's a seesaw. The more you turn one way, you change the amount of carbon and hydrogen and the amount of oxygen that's there, and it works in the reverse on the reverse side, right, where there's too much gas pressure. So that's why every different type of system have different ranges of whether it usually starts with where your oxygen wants to be. So if you want it to typically be between 6 and 9 or 7 and 10% oxygen, what am I supposed to do at 18%? Because you and I breathe 20.9. There's no mixture happening, right? You need gas in order to burn. You can't run combustion at 18%. I mean, you can. It just, what's going to happen is your efficiency is going to drop because you're too air rich. there has to be a way to have a better mixture in there. That 18% is not really something we can leave.
Yeah. So now I got onto the phone in this scenario, and I called the general of the project, and I said, "Listen, we need to do this right. We need the BAS hooked up. We need the guy here on site, or if you can do it remotely." And because the in the startup sheet, it asks for 6 stages of combustion and the readings, and I said, "We gotta come back and do this right, where he's going to ramp the gas valve up in increments so we can actually get low and mid and high fire and everything in between." That was like, and somebody had to go back and do that. Unfortunately, it wasn't me because I had other things to do, but someone went back and did that. But anytime you guys go to a startup, and this probably happens, you guys are involved in startups and commissioning of new equipment, get on the phone with the GC. Is everything finished? Does it have power? Does it have gas? Does it have building automation? Does it have a way to control it? Because if not, I'm not coming. Because I'm gonna bill you regardless. I'm gonna bill you my day to come out there and do whatever I gotta
Yeah,
do,
it's your
and
time. Sure.
you're gonna pay me, and we're gonna have to come back anyway and do it right when everybody's finished. So, I mean, it's just one of those things. Anyway,
Can I just jump in on one last thing on the
sure.
18? So when you see 18% oxygen, I swear to God, most of the time I'm like, okay, you got a crack or a leak somewhere in the analyzer because we shouldn't be anywhere near there. So if you're seeing numbers like that, there's one of two things. One, we're pulling in air from the room somewhere, and and this happens, right? So what you want to be sure is that you don't have a kink in your hose, or you don't have a tear somewhere in the water trap or something like that where it could be completely perfectly set up, and all of a sudden you put the probe in and I'm getting 18%. That can happen too. And that's because your analyzer might have a crack in the water trap or something that's causing air like water takes a path of least resistance, right? So we're it's leaking somewhere. So every analyzer brand has a diagnostic that you can go through, including ours. That's why they come with these little rubber hoses, and you can do a gas probe tightness test right in the field, and you put this little probe tip and it creates a vacuum on the analyzer to one, make sure that it's airtight, that we're not getting any leaks. So that would be my first step, just to be sure, hey, is this for real? Okay. And if it is, then that's the step you're talking about, is to moving on to something else, because 18%, like you said, your excess air is probably 1,000%. That means to in combustion, you're using 1,000% more air than is necessary for that burn. That's what excess air is telling you,
Yeah.
right? So it's too much, way too much.
Yeah. Well, if you think about it, we had 6% of gas valve opening. That's 6%,
Yeah, no, of course,
right?
right.
You know what I mean?
So
So,
as you open it up and you start introducing carbon and hydrogen, it starts using the oxygen, right? And creating CO2 and stuff like that. That's the whole purpose of a combustion mix. So you start to see that's why the content, when you turn the gas up, starts coming down, because it's being used for combustion. But you
correct.
want to
Yeah.
you want to have a little bit left over, which is the ranges that we want to see, but
Yep.
you don't want to have that much. You and I
Yeah.
breathe 20.9. If you're reading 18, it's like pure air. That's all it is.
Yeah. Okay, cool. So let's talk about how we set the Novo up. If you've already got one in your possession, how we get this feature onto the Novo,
Yep.
the cracked heat exchanger feature.
Well, the nice part is most of the things that we do on the Novo is upgradable in the field, right? So if you go, you can reach out to us. We can give you the instructions. It's very, very simple. It takes about a minute or two. Right on our website under service and support, we actually have you'll see, a section for manuals, and you'll see a section for firmware. So you can, if you have a Novo, whether it's 4 years old or 1 year old, and you don't have this feature, you want it, it's free. You just go to our website, follow the instructions. It walks you through step by step. Plug in the analyzer, turn it on. You need a laptop or a computer just to download it, and the file kind of automatic. You hit start and it automatically kind of downloads and updates the instrument. It takes about 30-40 seconds. Any new analyzer now already comes with that feature. And by the way, since we've launched the Novo about 4 years ago now, I think every year we've come out with some new major feature, cool new test or whatever, and we'll get emails from guys going, damn it, I just bought it a year ago. No problem. When it comes in for service, it gets updated anyway, or you can just go to the website and download the firmware and update it yourself.
Cool, man. Well, this has been a great discussion. I mean, we started with personal CO monitoring and had some chat around combustion analysis again. And I always enjoy talking to you because your passion for this part of the industry, it shines through, like it's very evident. So Jason, thank you very much, man. I appreciate this.
Gary, thank you for the time as always. It's always a pleasure, man. And I love what you do and what you put out there. And the more education, the more information, even if it's especially conversational like this, it means more. So anytime I'm available for stuff like this, anytime. The more education we get out there, the better.